Hello and welcome to this R tutorial. So in the following tutorials we're going to implement the Apriori algorithm, and as usual we're going to make this machine learning model to create some added value in some specific business. And in this part, this business problem is going to be about optimizing the sales in a grocery store in the south of France, and you're going to perfectly understand how the Apriori algorithm is going to do a perfect job at doing this, optimizing the sales. Because recently, a lot of stores considerably created some added value thanks to machine learning and especially association rule learning by using it to optimize the sales of their products. And how did they do that? Well, they just used association rule learning to know exactly where to place the products in the store. You know, for example, I'll give you a very simple example. If someone buys some cereals, well, this same person is very likely to buy some milk as well. So, by placing the cereals close to the milk, the store is very likely to put these two products into the same basket, even if the buyer originally intended to only buy cereals. Or I can give you a more general example. Suppose a person wants to buy a specific product, let's call it product A, and this product A can be associated very well to another product B, and the person who wants to buy the product A might not think of this good association between the product A and the product B. Well, if you place the product A and the product B next to each other, well, the association can suddenly pop up in the buyer's mind so that, the buyer can tell, hey, that's actually a good combination. Why don't I try these two for my next lunch or something? And so again, even if the buyer was originally meant to buy only the product A, well, due to this association that popped up in its mind, thanks to the placement of product A and product B next to each other, well, the buyer finally buys the two, product A and product B. So that's the idea of how we can create added value for retail stores or grocery stores. And so what we'll make in these future tutorials to optimize these sales can be also applied to any other store that is selling some different products. You can think of an online store. You know these recommendations, people who bought this also bought that. Well, these recommendations are based on association rules as well, but not only. It can be also the result of recommendation systems like collaborative filtering or content-based, item-based collaborative filtering, but association rule learning has a role to play. So now let's make our first association rule learning algorithm, which is the a priori model for this specific store in the south of France. So let's do it. As usual, we're going to set the working directory by going to our new part folder, which is the folder part 5, association rule learning. And we're starting with the a priori algorithm. So that's the folder we want to set as working directory. Make sure that you have the market basket optimization CSV file, and you can click on this more button here and then set as working directory. All right, we're in the right folder now. So the first thing we're going to do is to import the dataset. So the dataset is market basket optimization. So as usual, we're going to call it dataset, and then of course we're going to use the read.csv function. And now we simply input in quotes the name of the CSV file. So here we go, market basket optimization.csv. All right, so let's execute that and let's explain what the dataset is about. Here we go, dataset well imported. It has 7,500 observations and 20 variables. So let's check it out. I'm clicking on dataset here. All right, and that is the dataset. So the first thing that we can see here is that this line here contains some products, as these products here. And of course, these are not the titles of the different columns here. So to improve this, what we can first do is to add this header argument here, header equals, and then simply false, this way. And that tells R that the first line of our dataset doesn't contain the titles of the columns. So let's check it out now. Let's select this line and execute. Here we go. Let's close this and click again on the dataset. And here we go. We don't have any titles for the columns, but this first observation is no longer seen as the titles of the columns, but that's the real observation itself. Okay, so better. And now let's describe the dataset. So as I told you, we're making this a priori model for a store in the south of France. And so we want to find out the association rules of the different products of this store to see how the manager of this store can optimize the placement of its different products to optimize the sales. Okay, so the first thing to say now is that this store is located in one of the most popular places in the south of France. So a lot of people go into the store. And so, this place is a very convivial place, a very friendly place where people love to hang out, relax, talk to each other. And so these people come very often to this store because even if it's not to buy something, it's at least to meet their friends. And therefore, the manager of the store noticed and calculated that on average, each customer goes and buys something to the store once a week. So this dataset here contains the 7,500 transactions of all the different customers that bought a basket of products during a whole week. Indeed, the manager took it as the basis of its analysis because since each customer is going on average once a week to the store, then the transaction registered over a week is quite representative of what customers want to buy. So based on all these 7,500 transactions, our machine learning model, our a priori model, is going to learn the different associations it can make to actually understand the rules, such as if customers buy this set of products, then they're likely to buy this other set of products. So that's what we want to figure out, and that's what our a priori model will tell us. Okay. So each observation line here corresponds to a specific customer who bought a specific basket of product. So for example, if we look at line 2 here, that corresponds to one customer who bought burgers, meatballs, and eggs at a specific time of this week. And that's the same for all the other observations that correspond to other customers, or maybe the same customer who went back to the store another day or another time. So that's what the dataset is about, but actually this is not the dataset we're going to use to train our a priori model. And the reason is that the package we're going to use to build our a priori model, which is by the way the A-rules package, doesn't take a dataset like this as input. It doesn't take a CSV file that we imported thanks to the read.csv function. What it takes as input is called a sparse matrix. And so what is a sparse matrix? It's actually a matrix that contains a lot of zeros. In machine learning, you will encounter a lot of times the word sparsity. That corresponds to a large number of zeros. So a sparse matrix is a matrix containing a very few number of non-zero values. So what we're going to do now is transform this data set here into a sparse matrix. And can you guess what we're going to do? Well, what we're going to do is take all the different products of this data set, and actually I already know that there are 120 products, and we're going to attribute one column to each of these 120 products. So that means we'll get 120 columns. So for example, we'll have the column shrimp, the column almonds, the column avocado, the column vegetables mix, cottage cheese, energy drink, tomato juice, up to the 120th product that there is. We're going to see all the products then on a plot, but in this data set there are 120 products, which are, by the way, the 120 products of the store. So there's going to be one column for each of these products, and that's going to be the columns. And then the lines are still going to be the different transactions corresponding to each of the 7,500 customers that bought a basket of products during the whole week. But instead of having the list of the product they bought, we will have in each of the 120 columns here a 0 or 1. And it's going to be a 1 if the product is in the basket of the customer during its transaction, and a 0 if the product is not in the basket. So for example, let's take the second customer here. The second customer bought a basket of 3 products: burgers, meatballs, and eggs. Okay, so in our sparse matrix, we'll have one burgers column, one meatballs column, and one eggs column. They're not necessarily going to be next to each other. Burgers can be the 5th column, and meatballs can be the 9th column, and eggs can be the 12th column. That depends on how the A-rules package is going to make the matrix, but we will have a column for each of these 3 products. And so in these columns, since the customer number 2 bought some burgers, meatballs, and eggs, there will be a 1 in each of these columns. There will be a 1 in the burgers column, a 1 in the meatballs column, and a 1 in the eggs column. And all the rest of the columns are going to have a 0 value. And that's because all the other products were not in the basket of this customer number 2. So you can imagine that we're going to have a lot of 0 values. And that's even more true considering the fact that we have a lot of customers that bought baskets of only one product. For example, this customer number 10 here bought some French fries. this one bought some cookies, this one bought some mineral water. So, for these 3 customers who bought only one product, we're going to have only one column that contains a non-zero value, and all the other columns, that means all the 119 columns, will contain zeros. So you can see that we're going to have a lot of zeros in this matrix. And so for those of you who are discovering sparsity, I'm happy to introduce you to sparse matrices. So let's build this sparse matrix right now. You'll see that it's going to be very easy. So let's go back to our code and let's create this sparse matrix. So to create this sparse matrix, we're going to use a package, of course, and this package is the arules package. So we're going to install it and import it. So as usual, we're going to take the function install.packages, and then in parentheses, we just input the name of the package in quotes, and that's the arules package. All right. So let's check to see if I have it. Well, I already know I have it. It's actually already here and already imported. So that's the arules package, for which the description says that it's mining association rules and frequent item set. Okay, so mine is already installed, so I'm not going to execute this line. I'll just put it in comment. And so if you don't have the arules package here in the packages list, you need to select this line and execute. And this will install the package without any issue. And as far as I'm concerned, I'm just going to put that in comment. Right. And to make sure that the arules package is well imported, we need to add the line here, library, and in parentheses, arules. Already there, perfect. And that makes sure that if you execute the whole script, the arules package will be imported. And now we are ready to create our sparse matrix. So since our data set has no use here because we're not going to use it to build and train our a priori model, we will call our sparse matrix again dataset. Okay, and to create the sparse matrix, it's actually almost the same as importing a CSV file, because instead of writing here read.csv, we simply need to type read.transactions. Read.transactions, and then it's the same. In parentheses, we need to input the name of the CSV file. So we'll copy that and paste it here. That's the first argument. But then we need to specify to this function that the separator of our CSV file is actually a comma. So we need to add here sep equals, in quotes, comma. And why do we need to do this? It's because, our CSV file, if you open it with a text editor, you will see that the different products are separated by a comma. And we actually didn't have to specify that the separator was a comma here because that's the default separator of the read.csv function, but that's not the default separator of the read.transactions function, so that's why we need to specify it here. So sep equals comma, and actually we could stop here, but since I promised you to give you real-life data sets, I added on purpose some reality in the data sets, and this reality is about having some anomalies in the data. And these anomalies are actually some duplicates. Indeed, when this manager registered all the different transactions, well, he might have been very likely to make some human mistakes to put some duplicates in the data. So for example, if we go back to our data set, so that's the whole data set imported at CSV with the read.csv function. And so for example, when this transaction of the 31st customer was registered, one could make some mistake of putting twice light cream here, for example. And to train the a priori algorithm, we need to have no duplicate. So there is actually a good way to handle these duplicates. It's actually very simple because we just need to add an additional argument. If we look at the read.transactions function here by pressing F1, you can see that rm.duplicates argument. And as you can see, it's a logical value specifying if duplicate items should be removed from the transactions. So since the a priori algorithm is trained on transaction dataset that is supposed to have no duplicate values, we need to add this argument rm.duplicates and set it to true. And that will remove all the duplicates in each of the transactions. Maybe your dataset won't have any duplicates, but it's very common to have a few anomalies in datasets such as some duplicates. But here we will be fine thanks to this rm.duplicates argument. Alright, so we're now actually ready to create our sparse matrix. So let's do this. Let's execute this line and here we go. Alright, So now the sparse matrix is created. Unfortunately, we cannot have a look at it because, as you can see, if I click on this dataset here, the new dataset sparse matrix is not appearing here. That's actually the old one, so we can close this. But we can actually get some info about this sparse matrix. But before getting all this detailed information, well, we can see that we already have some information about the duplicate itself. When you execute this line to create your sparse matrix with the read.transactions function, including the rm.duplicates argument, you will automatically have this message distribution of transactions with duplicates. And here we see that we have 1, 5. That means that there are 5 transactions containing 1 duplicate. And for example, if in your dataset you have some triplicates, duplicates that appear twice in any transaction, well, you will have a 2 here and you will have the number of triplicates here. So that just gives the distribution of transactions with duplicates, and anyway now they're removed. So we can actually get some more detailed info about this sparse matrix. And to get this info, we, as we already did many times before, need to use the summary function. So summary, and here we input dataset. All right, and that will give us some info about the sparse matrix. So let's execute this line, and here we go. So what do we see here? First, we are reminded that this dataset contains transactions as item matrix in sparse format. So that exactly means that's a sparse matrix. And we can see that we have 7,501 rows, and we have 119 columns, and we can see that we have a density of 0.03 in this sparse matrix. And what does that mean? That means that the proportion of non-zero values is 0.03. We have 3% non-zero values and 97% zero values. Okay, then we have the most frequent items. So the item that is the most bought is mineral water. Yes, it can be very hot in the south of France, and it's a good French tradition to have a bottle of water during meals. Okay, then the French love very much eggs, they love spaghetti, French fries, chocolate, and that's all the other products. And then we have some interesting information about the distribution of the baskets of all the 7,500 transactions. So for example, here, this 1 associated to 1,754 means that there were 1,754 baskets containing only 1 product. And then we have 1,358 baskets containing 2 products, 1,044 baskets containing 3 products, etc. And we also have the quantiles of this distribution with the minimum value, the maximum value. So the minimum value is of course a basket of 1 product, the maximum value is a basket of 20 products, and on average, people put 4 products in their basket when they go to the store. Alright, so that's interesting informations, but of course we will get some even more interesting informations afterwards. And speaking of these more interesting informations, we can already have one now. It's actually going to be a visual information because we're going to make a frequency plot of the different products bought by the different customers in the store during this whole week. And so to get this plot very easily, we can use one function of the arules package, which is the item frequency plot function. And in this function, we just need to input 2 arguments, which is going to be the dataset. So that's the sparse matrix. So that's the first argument, and the second argument is top n. And that's the number of the most sold products you want to have in this frequency plot. So for example, if I put top n equals 100, I will get the 100 most purchased product by the French customers in this French store. So let's check it out. I'm going to execute this line. Here we go. And that's the plot. Don't worry, I'm going to zoom on it so that we can see better the products. And here we go. So that's the first 100 products most purchased by the customers. So that's kind of interesting. And if you want to have less products in this plot, you can just look at the top 10 and you'll get actually the first 10 products purchased by the customers, which are of course the same first 10 products. Okay, so this plot is actually going to be interesting for us for what's coming next, because we will have to choose a value for the support according to the Apriori algorithm itself. And we will be able to actually use this plot to look at the different supports of the product to choose a good value for our support. So that's what we're going to do in the next tutorials. We're going to start training our a priori model on our dataset, which is going to be this sparse matrix here that we just built. And so I look forward to building the a priori model with you. And until then, enjoy machine learning.